Thank you, Alex. Welcome everybody to Code Harbour. It's the first time I've been to Folkestone, but I did present at Canterbury a few years ago now. So it's good to be back out and doing live events again, and speaking to people in person. So thanks for coming. So today I'm going to talk to you about OWASP Top 10 2021. What I'm not going to do is go through them all, because I do not want to bore the tears out of you. So I'm just going to talk about them. But before we start, just give you a bit of background to me. My name is Glenn Wilson. I am a cybersecurity consultant. I specialise in the DevOps and Agile security space. Author of a book. I'm also a podcast host and a host of another meetup, a London-based one, on DevSecOps. And I'm also a freelance consultant with a couple of large retail clients at the moment, so it's good fun. So as I said, I'm going to talk about the OWASP Top 10. I'm just going to tell you what you need to know. And as I said, I'm not going to go through them for you because that will be horrible. So, can everybody hear me at the back? Yeah? Cool. So, what is the OWASP Top 10? Not what are, but what is the OWASP Top 10? Well, the OWASP Top 10, by the definition, is a standard awareness document for developers and web application security. And it represents a broad consensus about the most critical security risks to web applications. I'm not going to read off every slide, but that is an important definition of what the OWASP Top 10 is. I think the key words here to pull out of this is it is a standard awareness document. It's not a standards document, it's an awareness document. And it's for developers and security, and it specialises in web applications. So there is some use for it in looking at security of networks and so forth, but really this is about web application security. The first ever edition of the OWASP Top 10 came out in 2003. A consortium of security professionals decided that they wanted to create a list of the most common weaknesses and vulnerabilities and make it public so that people were aware of what they are, so that they can produce better software or better web applications. There's been multiple iterations over the years. They come out roughly every 3 to 4 years. And the reason why I want to talk about OWASP Top 10 today is because 2021 they came out, and it's a good time to actually remind ourselves of what the OWASP Top 10 are, and what it is. So 2021 is the current version, so they don't come out every year. So 2021 is the current version, there is no 2022. I doubt there'll be another one until about 2023, 2024. This is the current list of OWASP Top 10. And they're all common weaknesses that you will find in web applications. The way that these are collected, I'll go through this shortly, but the way these are collected, it basically tells us that these are the vulnerabilities, the weaknesses that are breached the most, are found within people's software, and we should really be careful that we are protecting our software and ultimately our customers' data, our customers' personal information, by focusing on these top 10. So how is the data collected? How do we do this, generate this top 10 list? So basically they go out to multiple organisations. They go out to vendors of security tools. They go out to bug bounty hunters. So bug bounty hunters are commonly called white hat hackers. So they don't do it for malicious reasons. They do it for the benefit of an organisation, and they get a reward when they find a bug or a defect. So it's quite a nice way of doing it. These are professional hackers, but they do it for the good of a company, not the bad of a company. And they're also collected from organisations that are willing to share their data. So any organisation that's willing to share their data on the vulnerabilities that they have. I don't know how many they had for the 2021 series, but I do believe they get around about 4,000 organisations respond to them with about 40,000 different data points that they collect from those organisations. So it's a large amount of data. they then take that data and they map it to what we call the common weakness enumeration. So the common weakness enumeration is a list of all the weaknesses that affect software. That could be anything like broken authentication or injection attacks and so forth. And they try to break those down into categories. Once they've broken those down into categories, they then try to map those. Once they've mapped those categories, they then look to see which ones are the most prevalent, which ones are the ones that are happening the most. And then they use some exploitability and some impact to then try to prioritize that. And that's how they come out with their top 10. So a lot of data, there's a lot of background, there's a lot of research that goes into producing these every year. And the one thing that I find quite extraordinary about the OWASP top 10 is that from year to year, or every time it's published, there's not much variation on them. They're almost identical from year to year. You always see broken access. So if you go back to that list, we always see broken access control, roughly in the top 5 every time. We see injection. Injection was actually number 1 from 2010, I think, all the way through to 2021. So for 10 years, that was our biggest problem. So that includes SQL injection, command injection, LDAP injection, just because you've not validated your inputs. Insecure design is a new one. That's brand new. That's brand new for 2021. It's been a controversial one as well because that doesn't actually have anything to do with any common weaknesses. This was based on consensus of what are or what constitutes a bad defect. So insecure design is an interesting one. But all of them there, all of these, you might recognise them. Identification, authentication failures. You know, where do you put your passwords? In the clearing GitHub? That's not the place to put them. Are you a developer with access to the production environment? Do you key in your password? Is your password shared amongst your friends and your colleagues? You know, that is what identification or authentication failures means. So how do we use the OWASP top 10? Well, one thing we don't use it for is, what we do use it for is an education program. We use it as a basic education program. We can inform our developers, we can inform our engineers what sort of weaknesses they should be looking out for. It's not comprehensive, it's not a comprehensive list, but it allows you to develop an awareness program. It gives us a minimum baseline for coding standards. Again, because it is only the top 10, it gives us a basic minimum baseline and the coding standards that we're using within organisations. So we can use the OWASP top 10 to try and create a very simplified version of that coding standard. And it also helps us do the security testing. So what we're going to test for, what sort of vulnerabilities can we find? We can then tune our automated testing tools to find out we can do code reviews to make sure that we aren't we're not writing code with weaknesses, the common weaknesses. We're not allowing SQL injection, passwords are managed carefully, and so forth. However, I'd like to give you a warning here. I'm not a vendor, so I can quite happily say this. Vendors, when they say to you, I've got this tool and it will detect everything in the top 10, in your OWASP top 10, they are lying. They can't. If we go back to the top 10, how the hell does a tool pick out insecure design? It can't. So when someone comes to you and says, our tool can detect everything in the top 10, ask them to validate that because they can't. Now, I mentioned that the OWASP top 10 is great for the bare minimum. Yeah, but I guess also we want to try and think about making our applications ultimately really secure. So although it's great for creating an awareness program, it's great for basic coding standards, and it's great for basic code reviews and testing, these are all minimum requirements. But we want to go beyond that. So therefore, OWASP has come out with a supporting framework. It's called the OWASP Application Security Verification Standard. And this is a great tool because it's much more comprehensive. It's like a checklist, basically, of all the security controls that you should be putting into your applications right from day one. It allows us to create testing frameworks for our applications. And also, as I said, it's got a checklist of requirements that we can go through to make sure our applications are very secure. Once we have an idea of what sort of things we want to do with our software security, we should come up with a program. Security doesn't just happen. It needs concerted effort from engineers, from everybody, security teams, from management. Everybody needs to be involved in making security valid. Now, people might be saying, yeah, but security is always a low priority. Well, actually, the number of breaches in 2021, according to a study by IBM, was at its highest point. I think the number that I read is that the average company now sees a breach of $3.8 million every breach. Now that's, I think, is about 30% higher than 2020, which was about 20% higher than 2019, which was about 10% higher than the year before. In other words, growing exponentially. We're getting bad at doing security, so it's very important that we have an AppSec program. So OWASP has got some guidelines about how to create an AppSec program. First of all, you need to identify the gaps, and you do this by doing an assessment of your application and your infrastructure using something which is very useful, the Software Assurance Security Model. I've used this several times with my clients, and it's a great way to establish where the gaps lie in security within an organisation. It doesn't find the threats and the vulnerabilities, but it works out where the weaknesses are within your own organisation in adopting security and implementing security. So it's a good place to start. Then you need to close those gaps. Once you identify those gaps, you need to close them. And you also need to share that with your engineering teams. The engineering teams need to know how to close those gaps. And that is where we come back to a more comprehensive education program. We need to teach our developers and engineers how to do security well. It won't just happen. We can't just rely on tools. We have to do it well right from day one. Of course, you then want to migrate all your applications into the application security program. You want to spread it out across your organisation. You don't want to just focus on your critical assets. You want to do it across all your organisation. A weakness in one part of your organisation could lead to your critical assets, and you might not realise that. So it's very important. And then, this is the important one. Once you've put your AppSec program in place, has it actually reduced your weaknesses that are common in the top 10? Don't you find them in the top 10? Because if it has, then it means your AppSec program's working. If it hasn't, then you need to go back and look at your program again and see how you can implement it. So that's how you would use the OWASP 10 in this instance. It's by using it as a tool to benchmark where you currently are in your AppSec program. And then you need to mature it, of course. You need a mature AppSec program. You don't just do this as a one-off. You iteratively build on your AppSec program over and over again. More education, more analysis to find those gaps, and just keep on continuing building that program. So, as I said at the beginning, I'm an author and I've written a book. And I sort of framed this into how we can build an AppSec program. And the way I've framed this is by creating 3 layers. The first layer, security education at the bottom, the foundation. It's so important that we as knowledge workers, which is what we effectively are in the industry, we know how to do security well. We know how to write good software. We know how to mitigate the risk. We know what the OWASP 10 means. We know what the common weaknesses are. We know how to fix them. The second one is we need to build on that education by developing good quality software. And when I talk about good quality software, I mean software that we as developers are proud of. Developers want to write good code, yeah? We want to do good stuff. But what we don't want to see are things like very cheap throwaway code that ends up in production, such as validation. If you're not validating inputs from outside your whatever you're writing, a function or whatever, input comes in, output goes into somewhere else. If that can be manipulated by an attacker, then you can end up with a SQL injection attack somewhere, or any other type of injection attack. So securing your application through design, designing the architecture, designing how you're going to do authentication, authorization, how you're going to build all that into your application goes into the good design principles. And then finally, you test all that. You have to make sure that you have security automation in place to test everything that you're doing. Now, the problem we have, and again, I'm not a vendor, so I can say this quite openly, security testing vendors come into your organization and say, I've got this SaaS tool, it will fix all your problems. It doesn't. It just adds more headaches to your problems if you haven't got these other two layers in place first. What will end up happening is you'll run a scan, you'll end up with 1,000 vulnerabilities, you don't know which ones are false positives, you don't know which ones to fix first. You're in a real pickle, and then you got everybody telling you that which ones you should be doing, which ones you shouldn't be doing, and then you just throw them away because it's just too much noise, so you don't bother. So security automation has to be built on top of the other foundations. Any questions? We've got a couple of minutes left. Any questions from anybody? Wonderful. If you do have any questions, that's how to get in touch with me. I'm on LinkedIn, on Twitter, Glenn.Eminet. If you scan this QR code, you will find my book. You can buy it online. I do actually have some copies here tonight. If you want to buy copies of my book tonight, I'm selling them a lot cheaper than you can buy them on Amazon, unless you're a Kindle, of course. But yeah, I'll be around. Any questions? Anything else? Oh, I've got a question about it.
I'm using all the questions, so I apologise if this is a stupid question. But you touched on it briefly when you said about kind of going deeper than the surface, dive deeper than those top 10.
Yes.
Because my initial thought was, it's fabulous information to always go down the top 10. But what if number 11, even if it's only 1% of businesses, what if that amounts to millions of pounds lost, billions even, across the country? Shouldn't we be providing solutions to that? Are we so focused on one area? How do you find that information? How do you find 11 to 20?
Yeah, so
you can actually build robust solutions for that as well.
yeah, so OWASP doesn't actually do 11 to 20 or 11 onwards. They don't actually do it. However, the common weakness in enumeration is a database that's held by a company called, help me here, Jonathan, is it MITRE? MITRE, yeah. They officially have a top 25, yeah, but they list all the common weaknesses that they come across, all of them. So if you are really stuck, you can go to the MITRE website, mitre.org, and you'll be able to download, or you'll be able to view all the weaknesses that you're likely to find. So you'll find number 11 and 12.
And then what's your opinion on that then, to build a more robust solution?
Yeah.
Go deeper?
Yeah, you definitely need to go deeper. But educating your engineers is the crucial part here, really. A lot of these weaknesses are avoidable if we know common sense engineering. That's the, if you're not validating your parameters, your inputs, that's common sense approach. You need more common sense. And that's the reason why my framework has that second layer of secure by design. You need that layer of good design principles. So yeah, I'm really sorry, but I've just moved away from the camera. It's just creeping.
It's all right. I don't do enough, clearly.
Yeah, so anyway, thank you very much everybody for listening. I'm going to be sticking around for a bit, so if you do have any other questions, then do please come and speak to me.